Surface dilation exercise number 2. Resuming from where we left off, I've only gone and taken the measurements of each side of the new triangle along with its perimeter and its area. Now I want to check the ratio. So simply all I have to do is to go to the number menu and calculate, and I'm simply going to calculate the ratio of the corresponding side. So side K in ratio with K prime, okay, or should I say, perhaps rather than going to large to small, I'm going to go small to large. Let's try it that way. It doesn't matter much, but it'll be more consistent um, with what we're going to try to show you with the scale factor down here. So again, we're going to select a ratio of K prime to K and click on OK. We're going to drag that over here. Let's take the ratio again. Calculate the ratio of J to, that is J prime rather, to J. Okay, we'll take a ratio. We see that's consistent. We also see that that is the same ratio as the sides down here, and that should be consistent here as this becomes close. Let's say it's 0.25 ratio. The sides are in the same ratio. We also have a theorem that tells us that if the ratio that is the same, the ratio for the sides is equal to the ratio for the perimeter. So let's check that as well. So let's check the ratio of the perimeter. So the perimeter of the smaller one divided by the perimeter of the larger one is consistent, also a 0.25 ratio or a 0.5 ratio, consistent with down here. The areas will not have that ratio. Let's get this to a 1 to 2 or 0.5 ratio here. Now, if I compare my ratios of the areas, okay, they will not be in the same. They will not be a 0.5. Let's see what they will be, okay? So we will choose to select the calculate and select the ratio of the areas, okay, divided by the ratio of the larger one, okay, the area of the larger one, and we have that ratio is 0.25. Or if we say the ratio of the small to large is 1 to 2, that's to say the large to small in terms of its perimeter is 2 to 1. Yet the ratio of the areas is now 4 to 1. And we can just validate that. Perhaps if we go to maybe a triangle here, which is 1/10 the size, okay, of the original one, okay. No, 1/10 is now right here. 1/10 is right here, okay. Then the area of the larger one is 100 times, okay, bigger than that. It is exactly the ratio of their perimeters squared, okay. Obviously, if this ratio is 0.1, when that is squared, it's 1/100.